Hi students, now we will discuss about the equations reducible to standard forms. Actually, we know that we have four standard forms. Okay, four standard forms. Now these are the equations of this type. Function of x power m into p comma y power n into q is equal to 0, or f of x comma m into p plus y power n into q comma z is equal to 0. Okay, x powers like x square, y square, something, yeah, where m and n are constant. So these type of equations can be solved by reducing it to, okay, reducing it to any one of the standard forms. Okay, as we know that we have four standard forms, so we try to solve these types by reducing it to any one of the standard forms. Okay, so here that depends on the m and n values. We have two cases. Okay, depends on the m and n value. So here case 1, first we'll discuss about the case 1, when m not equal to 1 and n not equal to 1. So apart from the 1, we can have any another value like 2, 3, minus 1, minus 2. Okay, in that case, see, when m not equal to 1, we are simply saying m not equal to 1 and n not equal to 1. That means m can be any other value other than 1. Okay, not 1, so any other, some other value. So in that case, in order to transform this, what we'll do, we'll try to reduce, okay, reduce the given problem by using some transformation. That is here use some another variable, put x is equal to capital X. Okay, we are transforming into some other variable. Capital X is equal to x power 1 minus m, and capital Y is equal to y power 1 minus n. Okay, so remember, this is what, when the degree of x, that is m not equal to 1 and n not equal to 1, we just put in capital X is equal to x power 1 minus m, and capital Y is equal to y power 1 minus n. Okay, so then the given equation reduces to here like in this form. Okay, reduces to in this form like f of 1 minus m into p, capital P here, 1 minus n into q, capital Q. Okay, so m 1 minus m and 1 minus n are constant, so which is of the form f of p comma q. So you can remember this one is a standard form 1. So now we know that how to solve the standard form 1, but it is what is the difference? It is capital P and capital Q, but the procedure is same. Okay, but the procedure is same. Yeah. Okay, so now let us take a look at the problems here. So now let us solve one problem. Solve, okay, x squared by p plus y squared by q is equal to z. Okay, so this is not belongs to any one of the standard forms. This problem you can observe, it contains all the variables here, x, y, z, p, q. Okay, it's not, it doesn't belongs to any one of the types, standard types. Okay, now so what you will do first, given equation can be written as like this. Okay, I'm taking this p to the numerator, so that can be whole, this something like px whole power, in that form you have to write, but this x square I'm writing as minus 2 whole power minus 1, and the p I took it to the numerator, so that is p whole power minus 1. So like in this form you have to write. Okay, so similarly this one also is equal to z. Now we can observe x power m into p. Okay, let us make it every term these has some combination as a px qy in the numerator, so that's why we are writing the given problem in this form. Okay, let's bring it to the numerator, so that's why I'm writing here, because since I have x power 2 here I have, but p is whole power minus 1, p is a power minus 1, so that's why I took it as x power minus 2 p whole power minus 1. Now minus minus plus from the given problem. So this is of the form f of x power m p comma y power n q comma z is equal to 0. Now here what is m? Minus 2. That is x power m or y power n. Here m is minus 2 and n is minus 2. Now you can see use the transformation, put capital X is equal to x power 1 minus m, that is x power 1 minus minus of 2 is x cube, and capital Y is equal to y power 1 minus n, that is y power 1 minus of minus 2, that is y cube. Now we know that what is small p is equal to dou z by dou x. Okay, small p is equal to dou z by dou x. I am rewriting this one as a dou z by dou capital X, dou capital X by dou small x. Okay, I am rewriting this dou z by dou x as a dou z by dou capital X into dou capital X by dou small x. Okay, just assume this as a capital P, dou z by dou capital X, capital P, and we know that dou capital X by dou small x, since you know that capital X is equal to x cube. By differentiating this, capital X is equal to small x cube, dou capital X by dou small x is equal to 3x square. So that's what 3x square we have written. Okay. Now here you can observe this, where capital P is equal to z by dou x. Now x power minus 2 small p is equal to 3 into capital P. Okay, x power minus 2 p is equal to 3 into capital P. Okay, now similarly we will do the y power minus 2q is equal to 3q, where capital Q is equal to dou z by dou y. Okay, so you got it? Yeah. So now substituting all this in the equation 1, the equation 1 becomes 3 capital P whole power minus 1 plus 3 capital Q whole power minus 1 is equal to z. Okay, is equal to z. So this is of the form, you can see the standard type 2. Okay, standard form 2. ZPQ is equal to 0. Now what is the procedure? Let z is equal to their f of x comma a plus y we just used. Now here z is equal to g of capital X plus ay be the solution of equation 2. Now what we'll do, capital P is equal to dz by du and capital Q is equal to a into dz by du. Okay, now equation 2 becomes like this, 3 into dz by du whole power minus 1 plus 3a into dz by du whole power minus 1 is equal to z. Okay, so now what is the common in this? This one can be written in this form. Okay, power minus 1, so we can reverse this. And now what is the common? 1 by 3 du by dz is into 1 plus 1 by a is equal to z. Z dz is equal to a plus 1 by 3a into du. So now integrating, separate the variables and integrating this. Integrating, so z terms on one side, here we have z dz is equal to a plus 1 by 3a into du. Integrating this, z square by 2 a plus 1 by 3a, it's a constant u plus c. What is u? It's a capital X plus ay, capital X plus ay plus c, plus z square by 2 is equal to a plus 1 by 3a. Okay, and what is the capital X is small x cube plus a by cube plus 3, which is the required solution. Okay, whatever the transformation in the middle, in order to solve the problem we have used, at the end of the problem we have to do the substitution. Okay, in place of original variables, whatever the duplicate variables we used, at the end of the problem we have to substitute that original ones. Okay, so this is the required solution of the given problem. I hope you understand. Thank you.